recording.
For the question one, I answered true because um, if we use the Fubini theorem, and then if the function is continuous, is continuous over the region that we are defining, and then we should be like able to change the order of integration. So in here, when we change the order of integration dx dy to dy dx, and also the lower limit and the upper limit for each of them is also changed. So I would answer the answer is true. For this question, we are going to find um, since we are changing the order of integration. But the thing is that they have in their lower limit and upper limit bound, they have the variable x. So we need to consider when we're trying to change them, like we need to find the limit again. So when I find that for the y, the max and minimum will be 0 to 1. But for the x, that will be y to 1 because y equal to x has becomes the plane for the x, and then the highest the maximum bound for the x would be 1. So instead of 0 to x and 0 to 1, that should be 0 to 1 to n y to 1 for dx dy. So the answer is false. In here, the question is asking if the limit is going to be 0. So first we try to simplify the limits, and then I separate them into the integral for y and integral for x, and then when we're trying to integrate that, it is e power y squared and sine y dy, and then the other one would be like e power x squared dx. So when we're trying to find that, we notice that e power y squared sine y dy is an odd function. So whenever there is an odd function and then we are trying to integrate them, then we will get a 0. So the answer is true. In this question, since dy dx and their limits, the upper bound and lower bound are the same and then they are equal. So that when we try to separate them, that will becomes integral from 0 to 1 f of x dx and integral 0 to 1 f of y dy, and then they're equal. So if we just try to think that f of x dx is equal to x, and then f of y dy is also equal to f of x dx. So that will become square of x squared. So we can technically think that the statement that is given in the question is true. So for the number 5, uh, the question is asking if that limit is less than or equal to 9. So in this kind of question, I would use the rounding theorem. So on the other side, it should be greater than uh, small m or equal to small m. And then on the right side, that will be less than or equal to greater m on the R region. So that will become, we will be multiplying both sides with the area. And then in this case, they're asking which one, what number they're like can't be greater than. So that is like we were trying to find the measurement of that. So first, I try to find the measurement for the sine a squared y squared. Since yeah, for that one, the measurement will be one, so it's like less than or equal to one. And then I try to find the measurement value for the a squared plus y square right y. For the x is the measurement is one and y is four. So I plug those numbers into the a squared plus square y, and then I get three. So I plug this into the integral, and then that will becomes 3 times 3 is equal to 9. So it means that the statement is true. All the numbers is they're asking the integral for them for from that. And then first we try to find the integral of that, and then we simplify the integral, and then we get the integral. But the other way that I'm going to do is finding the volume, not using the integral, and then comparing the integral answer and then the volume of the cone. So when I find the volume of the cone, I got 16 by 3 pi, and then the integral gave 8 by 3 pi. So they are not the equal answer. So that means that the integral is not true. Oh wait, no. Tom, can we go back to number six? I think I got confused with the 6 and 7. 6 is correct. I found yeah, I confused with 6 and 7. 6 is supposed to be true. And um, for that one, I just use the integral, and then I simplify all of them. Doing that, finding the integral, I use the USAB, and then from that, I got the answer of 16 by 3 pi. So the answer for 6 should be true. Uh, 7 is false because it was the one that I was explaining earlier. Because uh, 7 is false, and then 6 is supposed to be true. Can we go to another question?
Yes.
So for the 8, I first tried to draw the region that we are given. So we got the triangle with the vertices 1 comma 0, 2 comma 1, and 4 comma 0. So I tried to find the integral from that, and then I got the answer 53 by 20.
3 pi. Like this.
Oh, 53 by 20. So for the number 9, I set up the integral for that. The integral would be from 0 to 2, 0 to y, and then 0 to 1 minus 1 by 2y. And then we have 1 dz, dx, and dy. So by simplifying dz, I got 1 minus 1 by 2y, dx, dy. And then from that, I just integrate in terms of x with respect to x. And then I got y minus half y squared dy. And then I simplify it again, find the integral again, and then I got 2 minus 4 by 3y. So the final answer will be 2 by 3.
2y. Can you repeat the number? Can you repeat the number? I'm sorry, I was muted all the time. Can you repeat the number?
No, it's okay. It is 2 by 3.
2 by 3.
Yeah. So for the question time, we first we need to set up the integral. So when we set up, I also set up the integral in terms of r and theta. So we will get 0. The lower limit and upper limit for the theta will be 0 to 2 pi, and then r would be 0 to 1, since the radius is 1. And then we will get r squared minus r cubed dr d theta. And then when we integrate that, the final answer would be pi over 6.
What's the final number? I'm sorry.
Pi over 6.
It is?
Yeah. So for the 11, we are also using the polar coordinate to evaluate. So when we try to find that in terms of polar coordinate, the lower limit and upper limit for that will be, for the theta will be negative pi over 2 to pi over 2. And then the lower limit for r would be 0 to, and then the upper limit will be 3. And then we have the function in there is r cubed cosine theta, and then dA is equal to dy dx is equal to dA, so that dA will be equal to r dr d theta. And then when we integrate that, we will be getting the final answer of 4/8 over 5.
4
8 6 over 6 over 5.